is a transformation that produces an image that is the same shape as the original, but not the same size. Thus, it does not maintain congruency. All right, the three we've learned about before: translations. What's the second one we learned about? Reflections. And then the last one? Rotations. All maintained congruency. Dilations is another form of a transformation, but it does not maintain congruency. Everybody's filling these notes out, right?
Yes, ma'am.
Okay. A dilation is similar. This is the word where the word similar comes into play to the original figure. Because it is not congruent, it is similar. Same shape, not the same size. Dilations are centered around the origin unless stated otherwise. And for us, it will always be about the origin on the coordinate plane. Dilations are either an enlargement, which means the shape or the side or the figure gets bigger, or a reduction, which means smaller. So you have two types of dilations. First one is an enlargement, and the second one is a reduction. Scale factor is found by putting new over old, which is a ratio. Okay, a ratio is what? What's the other word for ratio?
Ratio.
Fraction. Okay? And what we do is we say to find scale factor, you just say, what does that spell? No. Just say no. And what that stands for is new over old, or you could call that, it either could be old or original. Okay? We generally say old, new over old. Okay? But it is the original size. Or, okay? If the scale factor is greater than 1, the figure becomes, what did we just say? Does it become bigger or smaller? Bigger. Larger, because it is greater than 1. Whenever you multiply something times a number that is greater than 1, then that means that it becomes larger. So scale factor greater than 1. Okay? If the scale factor is less than 1, the figure becomes smaller. Okay? So that is scale factor less than 1. What happens if the scale factor is 1? And this is, I believe, a test question. What happens to a figure if the scale factor is 1? It stays exactly the same. That's correct, okay? It's the same, or you could say that as it's equal, right? Because when you multiply by 1, you get the same back, don't you? No matter what you multiply. Okay? So here's your general rule, because we're all about rules in geometry in 8th grade. It says, if you have an x, y coordinate pair, and you change it by multiplying the scale factor times the x and the scale factor times the y, and that's how you find the new image, okay? Or the new side length. So you take that scale factor and multiply it times your x and your y. The other thing you can do is take your, let's do this, side length, because side length, and you just multiply your scale factor times that side length to find your new length. Okay? Because sometimes they don't give you a point, they give you a side length of a figure. Okay? So if your scale factor is 3, how would you write the rule? For any x and y pair, I'm going to change that x and y pair by multiplying the x by 3 and multiplying the y by 3. And that's what that says. I said 2, it's 3. Okay? So that means I'm saying 3 times the x value and 3 times the y value. So my scale factor, which we are going to abbreviate by saying SF, is equal to 3. So if I have a triangle, ABC has vertices. What's a vertice? It's where the 2 line segments come together. It's called a corner. Okay? It's a corner. So my triangle ABC has vertices of A, 0, 2, B, 4, 4, and C, negative 1, 4. Triangle ABC was dilated by a scale factor of 4 to create an image. Find the new coordinates. So, if this is A, B, and C, okay? And my old point of A was 0 and 2. My old point for B is 4 and 4. My old point for C is negative 1 and 4. What did we say we do? You multiply each one by 4. So you're going to have 4 times 0 for your x, and I'm going to split this like this, okay? So that these are my x's and these are my y's, all right? And then I'm going to take 4 times my y value, which is 2, and my new point, 4 times 0 is what? 0. So my new point would be at 0, and then 4 times 2 is what? 8. 0, 8. And now we know that as, how do we say this? A prime. A prime. Okay? That's your A prime. So then here we've got an x of 4, so 4 times 4, because remember it's scale factor times your x, and we could even write that up here if you want. Scale factor times x, scale factor times y, so we remember what we're doing. And here we've got 4 times 4, don't we? So my new B prime, my image at B prime would be 4 times 4, which is 16. And 4 times 4 is 16. So my new point would be at 16, 16. Kind of get the hang of what we're doing? So C, I'm going to take that same scale factor, 4 times what value? Negative 1. And I'm going to take that same 4 and multiply it times what for my y? 4. So now 4 times negative 1 is negative 4. And 4 times 4 is 16. And that's where C prime is. Is the new image larger or smaller? Larger. Why is it larger? Because scale factor was what? Greater than 1. That's correct. Our scale factor was 4. Okay? So is that an enlargement or a reduction? enlargement. And how would you write the rule? For each x and y coordinate pair, you are going to change them by, what are you going to do to the x? So you're going to put 4 times your x value and 4 times your y value. Make sense? That's not too bad, is it? Okay. All right. Here we've got where they want us to actually show on the graph, and I'm just going to show you what happens. Okay. So we're going to have to fill some of this out. It says quadrilateral PQRS has vertices of, I'm going to put my old points right now here. P is -2, 4. Q is at 4, 4. R is at 4, -2. S is at -4, -4. Okay? So I am going to draw, it says it is dilated by a scale factor of 1/2, find the new vertices. So, scale factor of 1/2. So, I'm going to go ahead and draw this figure first. I'm going to start at 0. I'm going over, remember this is your x-axis, this is your y-axis. I'm going to start at the origin and go to -2 on my x, go up to 4 on my y, and I am going to write right here P. Okay? Then I'm going to do Q, and I'm going to go back to where my origin is. I'm going to go over to 4 on my x-axis and go up to 4 on my y-axis and write Q. Okay? Going too fast? Okay. I'm at 0, 0. I'm going to do R. I'm going to go over to 4 on my x-axis and go down to -2 on my y-axis and put an R there. Then for S, go back to 0, 0. Go over to -4 on my x, go down to -4 on my y, and put my S. And what I'm going to do is I'm going to just kind of freehand draw this figure. So there is my shape. It's not perfect, okay? That's okay. All right? So now it says we need to dilate it by a scale factor of 1/2. So we're going to take our scale factor times our x. I'm going to split this little column in half, and the scale factor times our y value. Okay? So I am going to have 1/2, which, is it going to be easier to work with 1/2, or since it is, it would be. So how could I figure that out? I could do 1 divided by 2, math, enter, right? Now, if I did that, it would give me 0.5 back. If it gives you a repeating decimal, do not do it by the decimal. If it had been 1/3, it would give me 0.3333. You never multiply with a repeating decimal. So, if you just want to put in 1 divided by 2 in parentheses times -2, that's fine. If you want to put 0.5 in, because 1/2 is equal to 0.5, I'm going to use 0.5 for me. Well, I'm just going to do 1/2 times -2. If you use a fraction, it has to be in parentheses in your calculator. Okay? And I'm going to do 1/2 times 4. Since it's a half, how many people can tell me what is half of -2?
Negative 4.
Look at all these different answers I get. So, I want you to go ahead and put 0.5 times -2 in your calculator.
Negative 1 point.
Put 0.5 times -2 in your calculator and hit enter. What do you get?
Negative 1.
Come on, people. Half of 2 is what?
1.
1.
But ma'am,
That's what I told y'all.
negative 1 is bigger than negative
Call me
2.
Albert Einstein, bro.
What does that have to do with the price of tea in China?
So how is that half of negative?
Negative, but no. It has a bigger value than -2, but it is not bigger than -2. Okay? You understand the difference? Negatives and positives. That's what it has. It has a bigger value, but it's not a bigger number. Okay? Numbers. Here's your numbers. Okay? When you talk value of number, -1 is a larger value. Okay? Than -2. But half of 2, no matter whether it's negative or positive, is always going to be 1.
Oh, how is half?
Mind blown.
Oh, it's always going to be less than. Okay? You can't think about value when you're just doing this. We aren't talking about value. We're talking about the number. You just have, I know, it does. Okay? So, use your calculator to be sure. Alright? Value is different than just the number itself. We're not talking about value. We're talking about the number itself. Alright, so -1 and half of 4 is what? 2. And this is my new point of, I'm going to call it P prime, right? Okay? Alright, so then I'm just going to do 0.5 from here on out times what? 4. And 0.5 times 4. We already know what that is, right? It's 2. And that is Q prime. Okay? Now I have 0.5 times 4 again. And 0.5 times -2 again, don't I? So now I'm going to get 2 and -1 for R prime. Then I have 0.5 times -4 and 0.5 times -4, which gives me -2, -2, which is my S prime. So I'm going to plot this. So P prime is I'm going to start at 0, 0, go to -1, and go up to 2, and label it P prime. Next, start at 0, 0, go to 2, and to 2, and I've got Q prime. Start at 0, 0, go to 2, then go to -1, and I've got R prime. Start at my origin, go to -2, go down to -2, and I've got S prime. And now I'm going to freehand draw my shape. And you see how the figure is the same shape, but it is a different size, isn't it? So, is this congruent or similar? Similar. What do you notice about the angle measures? Very important here. Are the angle measures the same? Yes, because the angle measures are what maintains a shape. A square is only a square because it has 4 right angles. Okay? Does it matter if it's a big square or a little square? Doesn't it still have those 4 90-degree angles? Does that make sense to you? Okay, so angle measures stay the same. Very, very important to know that. Angle measures stay the same because same shape. Just because you change size does not, if you are the same shape, your angles are measures are the same. How do we write this rule for the dilation? XY changes by doing what? 1/2 x, 1/2 y. Okay? Now, if I wasn't given the scale factor and I was just given these two figures, there's a couple of different ways I could find the scale factor. Okay? First way. Let's do it right down here. There's plenty of room. Okay? Because I don't think... Oh, yeah, it's on the next page. We'll be all right. Okay, we'll look at it there. If the scale factor is 5/2, how would you write the general rule? What would you do? What would be the rule? XY changes to what? Somebody else. 5/2 times x and 5/2 times y. My question to you, is this an enlargement or a reduction? Why? That's correct. Just because it's written as a fraction doesn't mean that it's less than 1. Be careful. 5 divided by 2 actually gives you what?
2 whole.
2.5, right? Okay? So if you took, so it is an enlargement because 5/2 is greater than 1. If you did 5 divided by 2 and hit enter in your calculator, you would get 2.5. Okay? If the scale factor is 3/5, how do you write the rule? Somebody knew. XY change to 3/5 times x and
3/5 times y.
there you go. Okay? Is that an enlargement or a reduction? A reduction. Why? Because
Less than 1.
3/5 is less than 1. Remember, if you have an improper fraction, then you know it's greater than 1. If you have a proper fraction, what is an improper fraction? What do I mean? The top is heavier or bigger than the bottom. Okay? So if you have an improper fraction, it is going to be an enlargement. If you have a proper fraction, it will be a reduction. So, last little thing, how to find scale factor. All right, how to find scale factor. Quadrilateral A prime, B prime, C prime, D prime. That's how you say that. Is a dilation of quadrilateral A, B, C, D. Find the scale factor. There are 2 ways. Okay? What did we say? Scale factor is equal to, just say what? No, just say what?
What?
Just say
No.
no. No. What does no stand for?
No.
Okay, so which one of these is new and which one is old?
The big one and the big one.
Big one's old.
Little one's new.
Little one's new. Okay? So, they are on a diagonal, which is very, very hard to count. Okay? If they're on a diagonal, all you have to do is, we can't use a side length. So the first way is to use coordinating points. So I can choose any point I want. What do you want to choose? A, B, or C?
D.
Oh my goodness. A, how many ends? B, how many ends? C, how many ends? D, how many ends? All right, D it is. All right. All right, so if we choose D, we need the new first. So D prime is where?
0, -2.
D prime is at 0, -2. So we don't want to use zeros, okay? Because did you see when we were calculating scale factor over here, when we had it the very first page, when we had a 0 in it, when we calculated scale factor, did it change? No, okay? So you never, ever, ever, ever want to use zeros, okay? All right, it doesn't change. So we are going to come over here. We are going to use our Y values. So what is D? Where is D at? D. Where is D? 0, -6. You can use either both X's or both Y's. It doesn't matter. Okay? So if we are going to have to use our Y's because we do not want to use our X's. We don't want to use zeros. So our new one is -2, isn't it? Our old one is -6. I want you to put -2 divided by -6. All of you.
0.33.
Well, get it and hit math, enter, because you're not going to want to use a repeating decimal. What do you get? 1/3. So that's how you can find your scale factor that way. The other way you can find your scale factor is to use corresponding side lengths. Okay? And to use corresponding side lengths, what does the word corresponding mean?
Like,
they're kind of similar.
Touching.
They're the same side of two different figures. Okay? All right? This is 6 and this is 2, right?
Yeah.
Which one's new and which one's old?
The one on the right is 6.
Oh, the one on the left.
6 is.
No, the one on the left is new. The one on the right. No, the left. The one on the
The one
the
on
one
the
on the
right
left.
is
That one's
The
old.
one on the left.
So I'm going to put an O in it. So I remember that's my O. This is my N. I'm going to circle my two numbers. What am I going to write for scale factor? How do I need to find it? Just say
No.
N over O, which is no. I'm going to put what on top?
No.
2 over what on the bottom?
6.
6. I'm going to do 2 divided by 6. Math, enter, and what do I get? 1/3. You can never count a diagonal on the coordinate grid. We've talked about that. So if your shape only has a diagonal, you have to use the point. If it has a side length that's straight, like from here to here, then you could use that. All right? So, is the dilation an enlargement or reduction?
Reduction.
Okay, reduction. And why is it a reduction? Because scale factor is what? Less than 1. Are the corresponding angle measurements of the two figures congruent?
No.
Angle measurements of the two figures, are they congruent?
Yeah.
What does congruent mean?
Same.
The same size, right? And they are the same shape, right?
Yes.
So they have to be yes. And why do you think I keep asking these two questions?
Just want to make sure we got it right.
Because it's going to be on the test, isn't it?
they all usually gonna
Right?
be yes?
What?
Are they all usually gonna be yes?
No. Oh, the angle measures are always the same. When the figures are the same, even if they're not the same size, I said, you've got a little tiny square, right? How do we draw a square?
Dog, 4 lines, miss.
4 lines. So you've got 1, 2, and I know I can't draw a square perfect, but that's a square, right? Okay. What is right here?
A line.
What are those called?
Corner.
Angles. What type of angles are a square? 90 degrees. So we have 4 90-degree angles in a square. Do you agree?
Yep.
Okay. All right. I know I can't draw.
That's a right there, miss.
Okay. What do I have here?
Angles.
90.
90-degree angle.
Are they the same?
Yes.
I have 4 90-degree angles. So it doesn't matter about the size if the shape is the same. What maintains that shape and keeps it that shape are those angles. Okay? Alright? So that means that they will always be the same. And test question, there you go. Okay? Alright? Here we go. So, what's the general rule for this dilation? For every XY pair, change it by doing what?
1/3 times it.
And 1/3 times Y. Okay? That wasn't too bad, was it? Alright. That wasn't too bad.